As we speak, the night sky is undergoing profound changes that could alter its appearance within decades or even years. Astronomers worldwide have raised alarms, with figures like Neil deGrasse Tyson confirming Polaris, the North Star, is nearing a drastic transformation. This event's backstory is disturbing, as Polaris has been a constant reference point for navigation, culture, and science for millennia. Its potential disappearance would disrupt celestial navigation and erase a symbolic anchor for humanity. Polaris owes its uniqueness to its position near the celestial North Pole, appearing almost stationary in the northern sky. This alignment with Earth's axis has made it a guiding light for sailors, explorers, and astronomers. However, recent studies by the Royal Astronomical Society, September 2023, suggest this stability is fragile. The star's pulsation patterns have grown erratic, hinting at internal instability. These changes align with behaviors seen in stars nearing the end of their life cycles. The star's triple star system, comprising Polaris RR, AB, and B, adds complexity. Gravitational interactions between these stars influence their brightness and orbits. Any disruption in this delicate balance could trigger unpredictable changes. For instance, Polaris RR, the primary star, is a yellow-white supergiant 50 times larger than the Sun. Its sheer size makes it prone to violent reactions as it ages. Located 323 light-years away, light from Polaris takes centuries to reach us. This means if it exploded today, we wouldn't know until 2346. Such a delay complicates predictions, as current observations reflect the star's state in the 18th century. Scientists rely on historical data and stellar models to forecast its fate, but gaps in knowledge persist. Historically, Polaris has been a cultural icon. Ancient Egyptians linked it to their goddess Seshat, while Vikings used it to navigate the Atlantic. Its steadfast presence symbolized constancy in Greek philosophy and Native American folklore. Losing it would sever a thread connecting past and present. Modern astronomy also depends on it for telescope calibration and spacecraft orientation. Recent observations reveal troubling signs. The star's pulsation period, once steady at 4 days, has stretched by 4.5 seconds. While minor, this shift suggests core instability. Some experts blame gravitational tugs from its companion stars, while others argue it's entering a pre-supernova phase. Similar behavior was seen in Betelgeuse, a red supergiant in Orion, which dimmed dramatically in 2019. Betelgeuse's case offers parallels. Its brightness fluctuations sparked fears of an imminent supernova, though it later stabilized. NASA monitors it closely, as its explosion would be visible even in daylight. Unlike Betelgeuse, Polaris's changes are subtler but no less significant. The lack of NASA alerts for Polaris doesn't mean the threat is absent, only that data is still being analyzed. Stars like Polaris follow a life cycle spanning millions of years. Born from nebulas, they spend most of their lives in the main sequence phase, fusing hydrogen into helium. As fuel depletes, they expand into red giants or supergiants, becoming unstable. For massive stars, this leads to supernovae, cataclysmic explosions scattering elements vital for life. If Polaris goes supernova, it would outshine the Moon for weeks. The blast could create a neutron star or black hole, altering the Ursa Minor constellation. Earth, however, would be safe due to the star's distance. The real loss would be cultural and scientific, as generations have relied on it for direction and inspiration. The star's triple system complicates predictions. Polaris B, a distant companion, orbits the primary pair every 1,000 years. Its gravitational influence might accelerate Polaris A's demise by stripping its outer layers. Such interactions are rare but not unheard of. Binary star systems often experience violent endings. Light pollution already obscures the night sky for 80% of humanity. Losing Polaris would deepen this disconnect, erasing a shared celestial landmark. Future generations might rely on GPS instead of stars, but the symbolic void would remain. Efforts to preserve dark skies and educate about stellar phenomena are more urgent than ever. Astronomers use tools like the Hubble telescope and spectrographs to study Polaris. These instruments measure light spectra, revealing composition and motion. Recent data shows helium buildup in the star's core, a sign of advanced aging. Yet, without a complete model of its system, exact timelines remain guesswork. Public interest in Polaris has surged, with amateur astronomers sharing observations online. Citizen science projects like Zooniverse allow anyone to analyze star data, democratizing research. This collective effort could provide early warnings of stellar changes, bridging gaps in professional monitoring. The potential loss of Polaris reminds us of the universe's impermanence. Stars birth and die, galaxies collide, and black holes devour matter. Yet, this chaos creates new elements, planets, and life. Polaris's demise, while tragic, would contribute to this cycle, seeding future stars with its remnants. Subscribe to our channel and thanks for watching.